Dyes are essentially soluble in the medium they are used in, and therefore any crystalline features disappear in solution when a dye is used to impart color into a material. No longer is a particle, it actually dissolves into the plastic. There are no particles in the solution. You don't have to worry about dispersion because there's no particles to mix up. Here is kind of a tree of the different kind of soluble dyes, different families. Basically just 4 main families, and then there's a bunch of different kinds there, and names of all that. There's a whole bunch of them. But they all have those nice, long chemical names. Definition of a dye is that they are essentially totally soluble in the polymer system, and therefore any crystalline feature of the dye disappear in solution since the dye is now at the molecular level in the colored polymer. And one thing about the pigments is a pigment can actually act like a dye when you don't want it to, especially some organic pigments. You got to be careful that you don't use the pigment at such a low level that it will become soluble in the polymer. Then you get different colors. You can actually get fluorescent colors. If it's a pigment, you don't want it to be soluble at all, but a dye you do. Advantages, disadvantages of colorants relate to the specific applications. An individual property may be an advantage in one application and a disadvantage in another. So it depends on how you look at it. For example, in dyes, transparency is an advantage if you need a transparent color, a disadvantage when you need opacity. You'll have to mix it with usually an inorganic pigment so that you can get opacity. Advantages for dyes, they're very bright, intense colors, very transparent, excellent money value, especially in fluorescence. They can be expensive per pound, but you use them at a much lower level. In the lab, we have maximum loadings for different kind of colorants. For the inorganics, maximum loading is 0.5%, which is the highest value. Inorganics are the weakest. Organic pigments are 0.25% maximum loading, and dyes are 0.1%. So dyes are very strong. So you don't need very much. Dispersion unnecessary, like I said, so you don't need dispersion aids. You don't have to worry about breaking down the particles. Easier to scale up in production equipment, again, because you don't have to disperse it. Uniform dispersion is important when you scale up to production equipment so that the color looks the same. Disadvantages for dyes, like I mentioned, transparency can be a disadvantage if you want an opaque color. You cannot reach the highest levels of heat and light stability, so you have problems. You want to be outside for a long period or use them in very high temperature resins. Some dyes sublime. That means they go from a solid directly to a gas. When you're processing them, that dye can come out of the front of the extruder, deposit on the inside of the mold, or even can float up in the air and deposit on the ceiling and on the rafters, turn them colors. Bleeding is definitely a disadvantage. You can't use dyes in flexible polymers like flexible PVC or polyethylene and polypropylene because the material bleeds out to the surface and you can wipe them off. Few dyes are FDA approved. They can't be used in food contact applications. And one of the reasons is that some of them have toxicity problems so that they can be hazardous if ingested. Remember probably was back in the 70s or so, there was a dye that was used in food, red color number 2, was it? That they took off the market because it was causing cancer. Or, I don't know what it was causing, but people get sick. Yeah, it wasn't actually causing that many people to get sick from it. When they do toxicology studies, what they do is one of the things they do is they feed rats incredibly huge amounts of it that nobody would ever ingest, and then they extrapolate from there. In some cases, if you're going to eat a couple pounds of it, then it's probably toxic. Well, that's what they do. They give them so much to get the results faster that it doesn't really correlate. They say when you talk about toxicology that anything's toxic if you have too much of it. Water is toxic if you can actually drink too much water. Normally you wouldn't think of it as toxic. Toxicity is very dose related. Next type of colorant is inorganic pigments, which is a combination of metallic or metalloid elements with oxygen, sulfur, or selenium arranged in a three-dimensional ionic or covalent bonded array. Generally, our inorganic pigments have a metal in them, and unfortunately for their use, some of those metals are toxic. You heard the term heavy metals: lead, chromium, molybdenite, selenium. Some of those are worse than others, but they can cause cancer. Again, back in the 70s, and I even heard a news report just this week about it, where the lead from paint, kids were eating the paint chips off the walls, little kids. The lead in the paint was making them sick, causing a lot of problems. They are trying to eliminate heavy metals from a lot of applications. The problem is that these pigments are very good. They're very strong, good colors, high heat stability, high light fastness, inexpensive, but they have that little tiny problem of being toxic. Can't have everything. The light is absorbed, light energy is absorbed by individual atoms. Electronic transition is localized. Electrons move from one energy level to another. You give off your light. Some of the properties of inorganic pigments: dull to intense colors. Most of them tend to be on the dull side. There are a few that are intense, and unfortunately, usually the intense colors are the heavy metal ones. They generally are opaque as compared to dyes or organic pigments. They absorb and scatter light. They're not tinctorially as strong. What that means is they don't have as good of a tinning strength. When you tint white with it, you need to add more of it than you would if you're using an organic pigment. Typically, they have larger particle size. Here are inorganic pigments, different categories, different families of them, and what colors fall in those families. There's quite a few of them. Most of them are synthetic, manufactured. There's a few natural ones that are used, not too much used in industry anymore. Iron oxides are the largest. What's another name for iron oxide? Rust. But it can be used as a colorant. But those definitely are not very strong. Here, I don't know how well you can see this, but I've taken some pictures of some manufacturers' handouts. These happen to be some inorganic. These are from Harshaw, which Harshaw hasn't been around for years now. This is now Engelhart. These are just some inorganic colors. Here are some reds. Tops are what are called mass tones, which is straight pigment and resin. The bottoms are white letdowns, which mixed with white. Here's a little easy to see the colors here. This is a Shepherd, which is a pigment supplier, product brochure, and you can see there's some of the colors, some names there, color index number, which is how we generically refer to pigments, and then some features and benefits. The pigment suppliers will give you data sheets like this to help you when you use their colorants. Here are some more inorganic pigments. These are infrared reflective pigments that, if you look at these graphs here, between these two lines here, that's the visible spectrum, and then everything to the right is infrared. And these pigments are designed to reflect infrared, which is heat, so they're good to use, for instance, in roofing applications. So the light is a form of energy, and it generally heats up the roof if it's a dark color. Black absorbs a lot of energy. But these, since they reflect the infrared, they reflect that heat away, so they stay cooler. It would result in less energy use for air conditioning in a building that had a roof with this type of pigment versus a conventional pigment. Infrared reflective pigments are a big market now in the inorganics. In addition to the color part of the pigment, the other properties are also very important. Advantages: they're opaque, scatter light, easily dispersed compared to our organics, non-bleeding. Since they have the larger particle size, they tend not to bleed and not to come out of the plastic. Generally chemical resistant, light fast, and heat resistant. Inorganic pigments are generally made in a high heat process. Since they're calcine is the term that's used, at maybe 1200 degrees Fahrenheit, if you put them in a plastic process that's 600 degrees, generally isn't going to hurt them, whereas a lot of organic colorants might not be able to handle it. Generally, they're not very reactive. That leads to their chemical resistance, light fastness. Disadvantages, generally the duller colors, not tinctorially as strong, so you have to use more of it. The larger particle size can cause problems, especially in textile applications where they make thin fibers, because the particle size get to a point where they're so big that they can actually break the fibers. Some are heavy metals we talked about, have some toxicity problems, and they're banned in certainly food contact applications. Even auto manufacturers are trying to get away from heavy metals just to get them out of the waste stream. Obviously, if you put a heavy metal color in your car seats, you generally aren't going to worry about ingesting them. You typically eat your car seats. Even kids don't eat car seats. They want to get those out of there just to get them out of the waste stream more than anything else. Titanium dioxide is the most used colorant in the plastics. Is, and should say, inorganic pigment there because of the titanium. That's the metal. The main advantages are its very white color, it's highly opaque, inexpensive, and there's many forms available. The companies that has members in the CAD is DuPont, and they make TiO2, and they have very many grades of TiO2. I think they've given us TiO2, and I think we have 4 or 6 different grades of TiO2 for different applications. Properties, there's 2 types of crystals, anatase and rutile. We generally use rutile in plastics. Non-selective light scattering, which means it scatters all wavelengths of light the same. That's what gives its white color. Opaque, heavy, so it has a high specific gravity. Very abrasive when you run it through your equipment. Heat stable, non-toxic. It's actually used in food applications. High refractive index, tends to clump up and pack together if you have it in bags. Weatherable, chemically stable, it's an IR reflector and a UV absorber. When you get the white material that you put on your nose so you get suntan, that can be titanium dioxide. It's also interesting that titanium dioxide is also used in regular sunscreen, suntan lotion, sunscreen. The particle size are so small that it's transparent. If you were to look at titanium dioxide particles, it's actually clear if they're small enough. Depends on the particle size again, what its properties are. Advantages, opaque, significant scattering, fair dispersion, non-bleeding, high chemical resistant, light fast, heat resistant, and economical to use. So it's, like I say, the most used pigment in industry. Some advantages is it's heavy, so it has, again, a high specific gravity, is opaque if you don't want the opacity, can be abrasive in your equipment, and actually throw a little bit in there when you're purging. Actually helps clean out some other colors. And it does have a large particle size like most inorganic pigments. Next type of colorants, organic pigments. Combination of carbon, hydrogen, oxygen, nitrogen, and sulfur atoms bonded together in conjugated fused ring systems. Bob Charvet likes to call, when you look at the structure of these things, chicken wire chemistry. It has all those benzene rings that look like chicken wire. Molecules are arranged in crystalline forms, and the absorbed energy is delocalized over the entire conjugated ring system. This leads to high tinning strengths and cleanliness of shade. If you want a nice, bright pigment, you'll need to use an organic pigment. Usually they're much stronger tinning strength, more chromatic colorants, and clean colors. Here's some families of organic pigments. See, there's a fair amount of them. When we get into the colorants class, we'll look at these in a lot more detail, what some of their particular properties are. Here's a data sheet from one of the pigment suppliers. It has phthalo green over there on the top, very common green organic pigment. You can see these are all phthalo greens, but but they're all slightly different. They have different product names. They have slightly different properties. So depending on your application, you would pick one of those versus another one. You can see these are mass tones and these are tint. So some of the differences are in color and some of it are more in other properties. Also down here we have carbazole violet, which is a very strong violet organic pigment, very deep mass tone, a little lighter there in the tint. And in this case, the tint is 1 to 5, which means 1 part colorant for 5 parts white. So there's more TiO2 in this. Some reds, different oranges also, mass tones and tints. See what those look like. I tried to take some pictures of some actual chips from a book. This is what some of them look like. But this is a picture of some organic pigments. Another one there, blues, violets, and yellows. One thing you can see here, they put that black line behind the chips to show the transparency. There's different thicknesses on those chips, so you can see the transparency at different thicknesses of the plastic, because that's important. Organic pigment properties, bright, clean hues, transparent, not quite as transparent as dyes, but still much more transparent than inorganic pigments. They absorb certain wavelengths of light, have a high tinctorial strength, high tinning strength, and relatively small particle size compared to the inorganic pigments. Advantages are its bright colors, transparency, and high tinctorial strength. Are disadvantages, transparency, depending on the application again. Organic pigments are generally more difficult to disperse. Generally speaking, the smaller the original particle size, the harder it is to disperse. Those particles tend to want to stick together and clump up, so it's harder to break them apart. Organic pigments will bleed more than inorganic pigments, generally not as much as dyes. Your classical, regular organic pigments generally have lower chemical resistance, lower light fastness, and lower heat stability. There are also a class of organic pigments that are called high-performance organics that have better properties for chemical resistance, light fastness, and heat stability. But generally speaking, those will be very expensive. Generally, when you are looking for better properties, that's when you start looking at more expensive special effect pigments. Up until now, we were talking about normal pigments. Metallic pigments, significant spectral reflectance takes place mainly on flat and parallel metallic pigment particle platelets such as aluminum flakes. These special effect pigments are platelets generally. They're flat and thin, and their special effect comes from the angle at which the light reflects off of the surface. You get a metallic appearance, but it also greatly depends on which direction you look at the particular metal flake. What that means too is you have to be careful when you process them, because generally speaking, when you process through dispersion equipment, you want to break up the particles. In special effect pigments, you don't, because you want to keep them in the flake form to get that special effect. I don't know how good these pictures will come out. Here, you can kind of see the specks in there. That is a metal flake paint on a metal surface, just to give you an idea of what it looks like. Properties, very opaque, flake-like particles. They act as a barrier. Pretty good weatherability. There are some hazards involved with it. Special color effect, chemically reactive, brittle particles. So again, you don't want to be careful. You don't put too much energy into it to break them apart. Heat stable, and can be pH sensitive. So you got to be careful what materials you put them into. And in general, very stable chemically. Here's another picture. There's a red. Advantages: the opacity, significant scattering, easy dispersion, no bleeding, chemical resistant, light fast, and heat resistant. Mainly they're used for their special optical effects. Used more so in paints probably than in plastics. There are some disadvantages. They're heavy. They have high specific gravity. Opacity can be a problem. Flow patterns, any of these special effects can show flow lines when they're produced in injection molding parts. instead of being a nice uniform color, you'll see lines of different color where the material flowed. And they do have large particle